Let's deal with awkward numbers in bonding. We're Canadians. You can do this because we have odd and even bills in Canada. While they were bills when I was a kid, and this young lady here was not the geriatric queen we have now. If the valence numbers are nice, even, simple ones like 1s and 2s, the bonding is quite easy. Sodium at +1, fluorine at -1, it's 1 to 1. Magnesium, +2, fluorine, -1, you just do 2 of one, 1 of the other, you've got it. But not all of them are this easy. Sometimes you get a dreaded odd-even split, or I like to say the 2-3 split, because that's the most frequent one. Now, the 2-3 split, the 3-4 split, 5-6, any kind of weird things like that are kind of like when you buy batteries and calculators. Bloody batteries come in packs of 4, the calculators seem to use 3. It's like they're deliberately doing it so you got something left over. And occasionally math teachers think that they can make a real-world problem by something like this. Mr. Nerdlinger wishes to buy calculators for his math class because he doesn't know about cell phones. But the batteries come in groups of 4 and the calculators come in packs of 3. So take batteries in packs of 3. So how many calculators and batteries must Mr. Nerdlinger buy so he completely uses up his battery supply without waste? None! Batteries are choking hazards. Are you crazy? You can't even legally fold paper in school anymore. Buy solar-powered calculators, for God's sakes. But this is what, a math teacher thinks is a practical problem. In their defense, science teachers, we kind of do the same things by saying things like, without chemistry, life itself wouldn't be possible. Yeah, but I don't need to know chemistry to digest my food. It takes care of itself. I don't need to know how the sun works to get a suntan. I mean, I love science, but that's not really a good explanation as why you want to study it. So I think you all figured this out. If you buy 3 packs of battery and 4 calculators, you'll have no leftovers till someone steals the bloody batteries out of your calculators. And if we had packs of batteries that came in 7s and the calculators took 8 batteries each, I think you could realize that 7 times 8, 56. 8 packs of 7, 7 packs of 8, you'd have the number. Let's return to money and this grand old gal here. The $5 bill is an interesting one in Canada because this prime minister of ours was a shapeshifter. You can put a different hair on him and he looks like anybody you want him to be. So when I was growing up, people made him into Mr. Spock, now Severus Snape. So we're going to take our shape-shifting prime minister on the 5 and pit him against the polar bear on the right. And Americans don't know how to do this because they don't have Twonies. So let's do this as a learning of chemistry by an example of teaching an American. Hi, I'm a stereotypical Canadian Mountie. I like to say a boot and have maple syrup with everything. I need to talk to you. I got some concerns. You bags and milk and colored money kind of people. I got to talk to you about some of your things. Sure enough. Would you like some maple syrup? No, I don't want any maple syrup. I want to talk to you about your silly, funny money. What do you mean? This thing. 5, it's colorful. But what in blazes is this? A 5 and a 2? How am I going to make change? They told me I need a toonie for the pop machine. How am I going to get a 5 and a toonie to agree? Oh, this is really simple. We have to look for what common amount of money they would share. So if I give you 5 toonies and you give me 2 5s, it's the same amount of money. You want to do that, boy? I'm fine with that. I'll have the heavier amount of money. No. It'll be the same amount of money. See, 5 $2 coins is $10. But $5 bills, 2 of those make 10. I don't know about this northern math. Take a whole lot of bags of milk to make me think about this. Well, let's try it another way, okay? Okay. Well, wait a minute. Let's not try it another way. I forgot where I was in my slideshow. Just get on with it. I found these now. What the hell are they? Just get in here with me, boy. Explain that. And put your hands down. I've not arrested you. Okay. That's a threenie. a threenie. Loonies and Doonies and, no, Loonies and Toonies. And a threenie. Yeah, yes, you can buy the threenies from the Canadian Mint, but they're considerably more than $3 because they're collectibles. Why would I want to buy it then? Well, no, you had a question about the threenie. How am I going to be able to make toonies work with threenies, smart boy? Well, that's really simple. I have this RCMP placard here that I can show it to you. So let's take your threenie. We'll take a toonie. And we want to find when they land on the same amount of money. Now this time, we're going to go for a common value of 6. 3 toonies and 2 threenies is 6. I don't know. It is this weird math. Those are completely different numbers. Listen, trust me. Drink some maple syrup. Your brain is sugar powered. Wait. Jumping Jehoshaphat. I think I've got this Canadian money figured out. You're telling me if I give you 3 toonies and you give me 2 threenies, it's the same amount of money. Yes, now you're getting it. By jolly, there is something in this maple syrup. Where can I buy it all? Oh, well, it's not really for sale. That would be the country. Still, what do you want for it? No, we're not selling it right now. Okay. Hopefully that's helped our American friends learn a little bit about making change in Canada. If you could explain that, then you already can balance equations in chemistry. You just aren't willing to take your math of money and move it to another topic. But trust me, you can do it. There's our toonie and threenie in chemistry. Magnesium is the toonie, nitrogen is the threenie. When will these two values collide? When will 2s and 3s land on the same number? Dun, da, da, da. There it is. The only way you can make magnesium nitride work is to have 3 sets of 2 and 2 sets of 3. It's the threenie-toonie thing. The only way magnesium nitride can be made is Mg3N2. Now, what if I was sadistic? What if I was a cruel teacher and I didn't like you and I wanted to give you technetium nitride? What are you going to do now? Huh? Do you think I want to draw this? But no, I do not want to draw this. And do you think I would want to mark it? Absolutely not. Because can you figure out where multiples of 7 and 3 will land on the same number? Pretty nasty. Let's have a look. 21, 7, 14, 21, 3, 6, 9, 12, 15, 18, 21. It's going to take 3 technetiums and 7 nitrogens. I do not want to mark that. You're crossing over. Just use your common sense now. Like this. Except this is wrong and I have to redo this slide. So I'm stopping here.